Earthquakes have been and always will be a fear and danger to many, and rightfully so. Every year, these plate movements claim millions of lives, along with billions worth of damages. They even have the power to cripple powerful countries in the span of days. However, due to humanity's advancement, mathematical functions like logarithms can be used to predict the magnitude of an earthquake before it strikes, hoping to minimize damage and casualties in the unfortunate event of an earthquake.
To start, logarithms can be defined as a quantity, representing the power to which the base must be raised to produce a given number. It can be used in many places in life, like measuring our salary, or in this case used to predict the magnitude of an earthquake, which is basically the amount of energy that the earthquake releases. The higher the magnitude, the more energy released. To put it in perspective, earthquakes with magnitudes below 5.4 only end with minor damages. Magnitudes 5.5 to 6.9 are strong enough to kill and fall buildings. Magnitudes 7.0 and above can cause destruction of whole cities near its epicenter.
These magnitudes are able to be measured via the Richter scale, invented by Charles Francis Richter and Benno Gutenberg of the California Institute of Technology. With the scale, scientists measure these earthquakes using seismographs, which can detect movement in the earth. The smallest known movement detectable is known as a wave with amplitude a to the base 0. Using logarithms, one can determine the magnitude m of an earthquake on the Richter scale using the formula m equals to log to the base 10 times a over a to the base 0, which a is the measure of the amplitude from the seismograph divided by the smallest amplitude possible to the common logarithm of base 10.
For example, if a seismograph detects movement which is 450 times as fast as a to the base 0, we will substitute it into the equation, making the equation m equals to Lg times 450 a to the base 0 over a to the base 0, as a would be equivalent to 450 times a to the base 0. With this, we are able to cancel out both a to the base 0's, leaving Lg 450. Lg 450 approximately equals to 2.653212514, rounding out to a nice 2.7. Therefore, this earthquake has been measured as a 2.7 magnitude on the Richter scale. An important note to make is that the difference of 1 on the Richter scale is equivalent to 10 times the difference in energy released. Therefore, a 3.7 earthquake would be 10 times bigger than our earlier 2.7 earthquake.
This is extremely important, as knowing whether or not to evacuate an area in the event of an earthquake is extremely beneficial to the country. This applies more strongly to the less developed countries along earthquake-prone areas. If a strong earthquake is detected early, they can mitigate damages and loss of life, saving lots of money, time, and most importantly, lives. On the other hand, it is also possible that the earthquake will measure very low on the scale and cause little to no damage, resulting in lots of unnecessary stress for civil citizens and unneeded panic for the population. However, should authorities choose not to take action without prior research and detection, it may be that the earthquake could be extremely major and clock highly on the Richter scale, wiping out the entire population and destroy everything in the near vicinity.
On top of all of this, seismologists will be able to use this formula to further their research in their studies of seismology. They may be able to use this information to find patterns in earthquakes, or find ways to prevent earthquakes altogether. Using their intellect, they may be able to find a solution to one of the greatest threats of humanity's survival.